Good day to you. Welcome to this session on the measurement of reinforced concrete staircase. And there you can see a picture of a concrete staircase. This is a single flight of stairs, and that is what we are going to look at. If we look at the drawing, this is the drawing. It is single flight of stairs, does have a foundation beam at the bottom. Then you've got your stairs, your landing at the top of the staircase, and there is a beam forming part of the main reinforced concrete structure. So we are not going to measure that as part of the staircase. That is a section through the staircase, and over here we see the plan. It is a single flight and the staircase is 1 meter wide. We are going to measure the staircase in the following sections. Firstly, that part we're going to measure as concrete in foundations or foundation beam. And then the staircase itself, we're going to divide into the two different sections. Firstly, the triangular sections, and then this shape, which is a parallelogram, we're going to measure separately. And then that part of the landing, we're going to also measure separately. So we're going to go straight into the measurement thereof. Firstly is to do the excavations for the foundation beams. Now this is, we're not going to dwell on this because it's work that we've done previously. So very briefly, I'm not going to look at the standard system clauses either. First item there, excavate in earth below natural ground level. There is natural ground level indicated. 4 foundation beams not exceeding 2 meter deep. Then if we look at the dimensions, the first one is the length of the stair or the width of the stair. So we're going to look at the length of the foundation beam. So that is our first dimension, is the 1 meter. Secondly, we look at the width of the excavation, and there we can see it is 300 millimeter wide. And then thirdly, the depth we get from natural ground level to the bottom. We've got a depth there of 0.37. And we're going to add the excavation for soft rock, also the excavation for the hard rock, and also the carting away of the excavated material, because all that material there will be carted away. There's no backfilling for this excavation. Then we move on to the risk of collapse to size of excavations for trenches and holes not exceeding 1 meter deep. And this is where we need to measure the risk of collapse on both sides of the excavation. So it is those two parts, as well as the ends of that foundation trench. So it is actually all around that we need to measure the risk of collapse. So there we can see it is 1 meter is the length of the trench, 0.37 is the depth of the trench, and times 2, that will give us the dimensions for that side and that side. And then we also need to provide risk of collapse to the end of the excavation. In other words, that length over there, as well as that length. We've seen that that is 300 and it is 370 millimeter deep, so times 0.37. Then our excavations, keep excavations free from water, which is an item. And then we do the reinforced concrete 20 MPa 40 millimeter stone in staircase footing. So we're going to measure that as the reinforced concrete staircase footing. And it is the length of the footing times the width of the footing, which is 300 millimeter wide, times the total depth of the beam, which is given as 520. The full depth of that beam, 520.52. Then we also need to measure formwork, because it says there's no formwork to the sides in the ground. So there we do not need formwork, but obviously for that part there, we will need formwork as well as the ends of this foundation. So the description there, formwork to sides of staircase footing above ground, not exceeding 300 millimeter wide. Have a look at your standard system for the measurement of formwork to edges. The unit of measurement is meters, and that dimension there is the 1 meter. We do not times it by 2 because that side there's no formwork because that forms part of your staircase. So we only need formwork to the front edge of the foundation beam as well as the 2 sides. In other words, we need formwork there, we need formwork there, and we need formwork that area there. So there is the 0,3. It is for that length, and there are 2 ends that we need formwork as just explained. Then we're going to move on to the measurement of the concrete in the stairs and the landings. Firstly, if we look at the standard system, it says there the different components, and one of those components is stairs inclusive of landing and beams. Now that beams does not refer to the beams which forms part of the concrete structure. In other words, not that one there, but if we have, let's say, 2 flights of stairs and there was a beam in the middle of the staircase, that beam there would have been included in the measurement of the reinforced concrete in the stairs and landings. So that is the standard system. It is measured in meter cube. So the description there, reinforced concrete, the mix in stairs and landings. Right, the way I've broken it up is, as I said previously, we're first going to do all the triangles, and let's look at the dimensions. Firstly is the length of the landing or the staircase, which is 1 meter. Then we look at that as a triangle. It says there 3,000 equal treads. And if you count the number of treads overall, you will see there's 10 of them. So we simply divide 3,000 by 10 to give us a width of the stair of a tread. That's 300 millimeter. Similarly, we look at the rises. That's a vertical part of a staircase. You'll see that the dimension is 1,500. There are also from that point to that point, there are 10 rises. So the height of each riser is 150 millimeter. So then we sit with a little triangle, the tread 300, the risers 150, and because it is a triangle, we times it by a half. So it's 0,30 by 0,15 times 10. If you count those triangles, you'll see that there are 10 of them. And because it is a triangle, times half. Then secondly, we look at this blue part, which is called the waist of a staircase. And to get the dimensions of that is simply, firstly, is the length. Now, the length of that waist, we can take that dimension there. In other words, we're going to look at a triangle. We're going to calculate that length, times it by the number of those treads, and that will give us the total length of from that point right up to that point of this parallelogram. And there I've done it. So to get that slope length there is the square root of 300 square plus 150 square. And that gives us the 335,4. That is that slope length there. And because there are 10 of them, the total length then of this blue part will be 3.35. So that's where I get the length of that waist times the width of the staircase, 1 meter. And thirdly then is that thickness. Formula for a parallelogram is the base length times perpendicular height, and that is given there as 0.13. And then the last part is the landing part. And if we look at the landing, the total length of the landing is 1,300, but that part of the landing has already been taken into account. So we need to deduct the 300 millimeter, the width of a tread. So the remaining part there is 1 meter. So that's a 1 meter times the width of the landing is 1 meter, and the thickness of the landing is once again is 150 millimeter, same as that side there. So the thickness of 0.15. And that is the measurement of the concrete in stairs and landings. If we look at the next item, it is the formwork. The formwork that's needed there to form the risers, as you can see in that image there. So the formwork to edges, risers, etc., not exceeding 300 millimeter. Right, it is not exceeding 300 millimeter high or wide, and it is simply the length of these treads. So the length of the treads we've seen is 1 meter, and there are 10 risers. If you look at that there, you'll see from that point, that one we've already taken. So there are a total of 10 risers. So it is times 10, and your reference there is risers. There's a standard system clause, edges, risers, and reveals not exceeding 300 millimeter high or wide shall be given in meters. There you can see once again the risers to form the formwork to form the risers of the stairs. The next item is the formwork to the bottom of the stairs, which is indicated as that red line there. We need to provide formwork there, that bottom of the staircase. There you can see the sketch thereof. That is the part going up of the staircase, and we need to provide formwork to the bottom there, right? And there's the description. If we first look at the standard system, formwork to soffits of solid slabs, etc., and soffits of stairs and landings. So the formwork to the soffits of the stairs and landings we can group together as one item, and then also look at the normal propping up. The normal propping up is not exceeding 1.5, exceeding 1.5, not exceeding 3.5, and thereafter in stages of 1.5. But it also says, subclause 43 there, no separation of height shall be made for formwork to soffits of stairs and landings. So when we describe the formwork to the stairs and the landings, we do not have to state any propping up categories as stated in that clause there. It is also measured in meters square. So we can go back to our description. It is simply formwork to raking soffits of stairs, no propping up categories there. And it is measured in meters square. And the way I've done it is simply by using that length of the waist, which we've determined in the previous item as 3.35, and the width of the staircase obviously is the second dimension to support that part of the staircase. Formwork to raking soffits of stairs. The next item now is for the formwork to form this edge, or to the edge of the staircase. Now, if you look at that there, that is the shape of that, right? So it's a formwork to this area of the staircase. And we describe it as formwork to raking and stepped. It is raking, goes up, it is not horizontal, it is not vertical, it is raking, and it is stepped. So there's where the description comes from. Formwork to raking and stepped. Outer edge of stairs, it's the outer edge of the stairs. And then the category, all formwork less than 300 is in the categories. And if it's less than 300, that clause there, where is it now? That one there shall be given together in one item as in measured in meters. This description is slightly different from the normal one because of the raking and stepped outer edges forming part thereof. Now we only know that that is 130 millimeter. We need to determine what is that length there. And the only way that I've done it is simply by scaling it. And I've determined that that is 270 millimeter. So it falls in the category of not exceeding 300 millimeter. We can safely say by scaling, it is less than 300. And that's where I get that description from. Not exceeding 300 millimeter wide extreme, because the extreme width of this outer edge is not exceeding 300. And once again, to get the dimensions, it is the 3.35, which is the length of that sloping part. That sloping part is 3.35, and it is for both edges. It is this edge and also the other edge of the staircase. And then the next item is the formwork to the soffit of the landing, that part over there. And it is simply formwork to soffits and landings. Remember once again, for that one, no separation of height shall be made for formwork to soffits of stairs and landings. So we do not have to state the propping up category for that description there. And the dimensions is simply the 1 meter there. The remaining is the 1,300 minus the 300 millimeter, gives us a total length there of 1 meter, and the width of the landing we've seen previously is also 1 meter. And then the last item is actually the formwork to this part, to the edge of the staircase. In other words, if we go back to our little drawing, it is the formwork to that edge there and that edge of the staircase. That is what this formwork is all about. So it is to that part there. We know that the thickness is 150 millimeter, so it falls in the category of formwork to risers, edges, not exceeding 300 millimeter wide. And it is the length, in other words, that length, 1,300 minus 300 millimeter, gives us 1 meter. And it is for this edge as well as the other edge. So that's why it is times 2. And that is the end of the dimensions for this staircase. Thank you very much. I hope you've enjoyed it. Look at the pictures, look at the drawings, and I hope you will be able to measure reinforced concrete in a staircase. Thank you very much, and goodbye to you.